comma y, which is given by x by y minus greatest integer of x by y. So the symbol greatest x means greatest integer of x, which you are already acquainted with, because we know greatest integer of 2.3 is 2, greatest of 2 is 2, and so on and so forth. So we need to calculate the value of this function. So before we get and dwell to the problem, the function is asking what some input x and y is there. Again, we have some xy, some xy, and so on and so forth. So it's better first let's try to appreciate what does this function look like. Okay, so we'll play with some of the value. Let's say put x equals 2 and y equals 3. So we are going to get 3. We have 2 by 3 minus 2 by 3 greatest. We know greatest of 2 by 3 is 0, so the answer is 2. Right? Let's have more fun. If it is 3 comma 2, so we get y is 2, 3 by 2 minus greatest of 3 by 2, which gives 3 by 2 minus greatest of 3 by 2 is 1 point something, which is 1 integer part. Hence we have answer as 2 into 1 by 2, which is 1. Fine. So can you see like f of 2 3 is 2, f of 3 2 is 1. Let's have more fun, and let's say 9 and 5 if we calculate. So you can just calculate. Let's do it over here. 5 into 9 by 5 minus greatest of 9 over 5, which gives 5 into 9 by 5 minus 1. So 5 into 4 by 5, which goes to 4. So now you can clearly see what's happening over here. So whenever we have some bigger problem of, especially of higher dimensions like 2023 or something, which is mostly in fashion nowadays in JEE type of questions, it's better to take some smaller case and try to get a feel of what exactly question is asking. So clearly from here, as you can see, like there is some pattern. So 9 and 5 is giving 4, 3, 2 is giving 1, and 2 and 3 is giving 2. But still the pattern is not so much, like exposed there in a very good way. So here we go. We'll do a little bit more experimentation, which I've done. So here we go. We'll do a bit more experimentation. So 10 3 if we'll calculate, we'll get 1. 7 2 calculation is giving 0. 9 3 calculation, as you can clearly see, it's giving 0. Okay, 7 3 calculation is giving you 1, because this quantity is going to be 3. So we have 2 into 1. So now you can see like there is some pattern in this. In fact, I can directly resolve this part as fractional part of x by y. Let's say if x is any number which is divisible by y. Of course, x and y integer according to the problem statement, because they're talking about 2023 and factorial and some 10 to the power 4. So x can be written as y lambda plus r by basic division lemma. Let's say we have a number x. When we divide by another integer y less than that, so we'll have some quotient lambda and some remainder r. So x we can write as y lambda plus r, right? So x by y will give just the value of r, because fractional part of y lambda plus r by y, since lambda is also integer, this is constant, so fractional part of some integer plus r by y. Now you know this will be fraction, because the remainder when divisible by y will be definitely less than y, so this fractional part just boils down to r by y. Now we have r and y cancelling, and we have an answer. So it's a very interesting answer, because you see what is the answer. The f of xy is nothing but r, which signifies f of xy is the remainder when y is dividing x, or when x is divided by y, the remainder whatever you are getting is this function, basically f of xy. So that's a simple function, and now you can convince yourself it's a remainder when 9 is divided by 3, so remainder was 0. When 2 divides 7, the remainder is 1, so that was the answer. When 3 divides 10, remainder is 1, and so on and so forth. So once you have understood this function, we'll go ahead to understand like how to calculate 23 factorial by 10 to the power 4 10. It means when this number is divided by 10, we want remainder here, right? Similarly, when this number is divided by 100, we'll get some answer, and a remainder we need to report here. So now it's better to investigate. Let's say when we divide 23 factorial by 10 to the power 4, what that number will look like. So 23 factorial will clearly end with some zeros, because it has got 5 and 4 and many combination of that. So let's try to find the maximum power of 10 in 23 factorials. As you know, if you'll directly write down 23 factorials 1 to 23 and you'll count number of 5 here. So 5 will occur in 5, 10, 15 and 20. So 5 is occurring just 4 times. So this is a basic rule of you can actually count 5. Then you can count how many 5 square is there. So in the second filtration, you are counting more 5s in the system. And in third iteration, you are counting still more 5s. So it's the usual formula for finding number of primes. Here even you can skip this and just count like 5 is coming from either 5 or 10 or 15 or 20. So these are the only 4 sources of getting 5. 2 can come from even 4, which will give 2 2s. So when I'm writing 23 by 2, I'm first like taking away just one single 2 from each of the factor. Then we know like we have missed one more 2 in multiple of 4, that's why dividing it by 4. Then we know like we have missed one more 2 in multiple of 8. To compensate for our loss, we'll get so many answers. Clearly the number of 2s will be much bigger, so that will be 16 plus something, which we are not interested. This also shows like how exactly you should solve the problem. Okay, unnecessary don't do calculation in JEE problem. So you don't need to actually find powers up to, you know, it will be definitely bigger than, like 5. So just the maximum powers of 5 is 4, hence the maximum power of 10 in 23 factorial is going to be 4. Which means like 23 factorial can be written as 4 some non-zero digit. We don't know how many non-zero is there. We don't care even, but it will end with 4 zeros because we know maximum power of 10 is 10 to the power 4. Similarly, you can calculate for 24 factorial and it will also, because just incorporating one number 24 will not add to power of 5, so it will exactly end with 4 zeros. So 24 factorial is also ending with 4 0 and the first non-digit number will be bn. Clear? Bn minus 1 may be 0, may not be 0, so we don't care and we can't comment about the other digits, but the bn must be non-zero and an must be non-zero because we have exactly 4 zeros at the end of the number. Now coming to the second part of the problem, as you can clearly see. Now coming to the second part of the problem, as you can clearly see, there is some pattern in this. So if this I call as x, so it is f of x 100 and f of x 10. Right, so we have f of x 100 minus f of x 10 over 10. What does this second part looks? It's also a same structure, f of some x 100 and f of x 10 by 10. Okay, so it's better to calculate the genetics of f of some number when divided by 100 minus the remainder when that number is divided by 10 divided by 10. Okay, so let's do and try to appreciate that calculation which I have done here. So till now, let me recapitulate what we have done. Just we have seen like 23 factorial by 10 factorial will end in 4 0. So this number 23 factorial will end in 4 0. So 23 factorial by 10 factorial will be just this digit, right? It's for 24 factorial by 10 factorial. And okay, so what we have seen just now, like 23 factorial will end in 4 zeros. So this term will be a1 to an, right? And if this will divide by 10, the remainder will be just an. So this quantity is nothing but an, right? Similarly, 24 factorial ends with exactly 4 0 and then we'll have bn as the first non-zero digit. That divided by 4 factorial will be just these numbers. So this will get cancelled. And if we'll take a remainder, so if I divide this number with 10, we'll get a remainder as bn, right? Because you take a number 123, it can be written as 120 plus 3. You divide by 10, this will be divisible. So the last digit will be the remainder, right? So now we have remainder as bn from here. Okay, so far so good. What about f of x 100? So again, x is either 23 factorial or 24 factorial. So if x is any number, okay, so let's say if x is this number, right? When that divided by 100 will give you the last 2 digit. Why? Let's say you have 1 2 3 4 5, this number. So this can be written as 1 2 3 0 0 plus 45. So any number can be written as last 2 digit plus 100 times something, right? So this is already divisible by 100, so the remainder will be 45. So if I have any number x alpha 1 to alpha n, where alpha n can be 0 also, I don't care. So in general, this will have a remainder, the last 2 digit. It's not multiplication, it's the last 2 digit. Like 4 5 I'm writing as alpha n minus 1 is 4 and alpha n is 5, which is basically 45, which means 4 into 10 plus 5. So 10 times this plus this one. I hope it's clear. So that's what I'm written over here. So with remainder we'll get alpha last 2 digit minus remainder with 10 we'll get just last digit divided by 10. Now you don't do mistake like you take alpha n common and alpha n minus 1. This is completely wrong because this does not represent multiplication in digit. So this last two digit can be written as 10 times alpha n minus 1. Valuation will just come to alpha n minus 1, which is this represents, you put a number x. Let's say if I keep a number 1 2 3 4 5, so it represents the second last digit of the number. Okay, so 4 is the answer for this entire thing. So if x is 1 2 3 4 5, this function f of x 100 minus f of x 10 by 10 will pick up just 4. If you take a number 9 9 2 7 5 6 7, it will just pick up 6. So that is the significance of this. Now coupled with these two tools, I can clearly see the given problem just boils down to, this is nothing but the first non-zero digit of 23 factorial. Okay, so which is n. 23 factorial, you see, ends with an. And then you have second term, which is the second digit. It means the second digit of 23 factorial, so which is n minus 1. Similarly, we have the first non-zero digit of before 40, so it is bn, because in 24 factorial was something like this. So first non-digit 0 is bn. The other function with 24 factorial was denoting bn minus 1. Now we need to calculate the sum of all these four guys, and that's the answer. So let me again tell you what we are evaluating. So this is an, this guy as a whole is an minus 1, and this guy is evaluated to bn, and this is bn minus 1. So we need to just add 4 of this answer. Now here is a very small and beautiful ideas. As we know, let's see how to add this. Now the problem is you don't know the first non-zero digit or the second non-zero digit or zero digit of the numbers without actually multiplying them. But the greatness of this question lies here. We know 23 factorial can be written as this. It's something ending with 4 zeros. 24 factorial is ending with bn and 4 zeros. What if I add both equations? Well, if I add both equations, clearly you see LHS 23 factorial plus 24 factorial can be written as 23 factorial into 24, which gives 23 factorial into 25. Now we know 23 factorial is already having, it's ending with 4 zeros, right? 23 factorial is ending with 4 zeros. Now when you multiply that 4 zeros wala number with 25, you imagine like you have something n and then 4 zeros, and you multiply with 25. When we are multiplying with 25, since already this numbers is having, because this is 23 factorial, so it is having 1 2 3 4 5 and so on. This 4 0 is because we have maximum 4 powers of 5, but still we are having excess power of 2, because 2 to the power more than 16 was there, and 25 itself contains 5 square. So of course 5 square will observe 2 square, and of course still many 2's are left, so that will create 100 extra. It means if I add these two, it will definitely ends with 6 zeros. Is this clear? Yes, because 23 factorial ends with 4 zeros, and definitely it will have, okay, so I can tell it's like 10,000 into 2 ka power again something, which is in excess, like definitely more than 5 or something. And then you are multiplying with 5 square. So overall product is going to be ending with 6 zeros, guaranteed. So this ends with 6 zeros. It means if I add both of them, it must ends with 6 zeros. And that's really crazy. And that's really crazy because now you can clearly see if I add, let's add like a kid. So 0 plus 0, 0, 0 plus 0, 0, 0 plus 0, 0, 0 plus 0, 0. Now we know the RHS must ends with 6 0. It means an plus bn must ends with 0. So it can be 7 3 to give 10, or it may be 9 1 to give 10, or whatever it is, maybe 6 4. We don't know what individual distribution of an bn is, but an plus bn must be 10, right? Because it has to ends with 5 0 and one more 0, still more constant. And now 1 is carried on. When 1 is carried on, now this plus this must be 9, so that when we add 1 to it, it will become 10, and then 1 will be carried further. So that shows like this must ends with 6 zeros now. Okay, so the takeaway is n plus bn has to be 10, and that 1 carried on, the next digit has to be non-zero. Okay, so this will be non-zero. Why it will be non-zero? Because it must end with exactly 6 zeros. It cannot end with 7 0. Okay, so this will be, let's say, alpha, and then let's say alpha n minus 1. So I'm sure like alpha n is non-zero digit, but alpha n minus 1 can be anything. So n plus bn is 10, and an plus 1 plus bn plus 1 has to be 9, and that directly solves the question. So these two guys is 10 and this 9, which is 19. So it is a very beautiful problem. The takeaway from the problem is, even if the problem feels very difficult or lengthy in the first go, have patience. You take some smaller and simpler case of it, do a bit experimentation. Of course, you have to do this fast in the examination hall. Since I was over explaining, so I took more and more simple examples. You could do in a smart way still. I hope you must have enjoyed the lecture, and moreover, I hope like this is useful for your coming JEE examinations, where divisibility problem from binomial theorem will definitely come, okay, in one of the question paper or in many. So